Okay, welcome back. We're on page 240 and 241 talking about this very, very pseudo-codish way of looking at things. So depth first uses a recursion thing, right? And then breadth first uses a queue. So the idea is that these two techniques using a queue are recursion. That's just, you don't actually have to use a queue. There are other ways you can do this, but just bear with me. So it does not use the application stack. It uses a built-in structure to keep track. Both of these have to figure out some way to mark where you are to make sure that you don't necessarily stop at the same location a second time. Just like in the idea of routers getting an update, it's okay to go through a router, but you don't want to go to the router and say, hey man, it's time for your update. It's like, dude, I've already got the update. Leave me alone. Right? So you don't want to stop. Okay, good. So on page 243, they talk about the analysis of these techniques, and this is a little strange. They make a statement here. When I first read it years ago, I went, what? Their statement basically is, let's assume that all the work that's happening is happening at the node, and that work is complex, and therefore the choice of traversal is not relevant. Okay. So the choice of whether I take the breadth first or depth first is really not relevant because they're assuming that that's trivial, and therefore all the work is like the traffic engineer. He's going to go out there. It takes him, 5 minutes to go to the next intersection, but he's going to spend 15 minutes there doing traffic counts, right? So how long it took him to get there is not all that relevant because he's going to spend 15 minutes doing traffic counts there. Okay, so the work being done is complex at the node is kind of it's kind of cheating because what that sets you up is saying, well, there's no difference between these techniques. Well, yes, there are. So they're saying because of that assumption that both these techniques are equally efficient. So basically a big O of n. In other words, if you add more, it's just completely linear. If you had one of these things that had 50 nodes you had to traverse versus 100 nodes, however long it took you to get to the 50, that's how long it's going to take you to get to the 100. And mowing grass, right? If you have a quarter of an acre to mow and you have a half an acre to mow, it's going to take you twice as long to mow the half acre, right? Come on. So yes, it's linear. It doesn't matter what technique you use. If you use the zigzag technique or the spiral technique, right? Who cares? Okay? Cool. Now, one more time. Does any of this discussion so far have anything to do with getting from point A to point B in the shortest amount of time? Please don't get that confused. We've talked about traversal. We've talked about the inner workings behind the scenes about whether or not we store it into an array or a linked list. We talked about two different techniques for traversal, and none of this has anything to do with the shortest path yet. Okay, so which technique do you think I use? Well, remember, both of these techniques would be really cool to come up with. Is this thing connected, right? It doesn't really matter which one. You could argue, if you had more nodes than edges, right? The ratio of nodes to edges was greater, then you could argue that one technique was better than another. But when it comes to reality, that's not normally the case. Typically, in every real world scenario that we're talking about, the numbers are almost always very, very close together, the number of roads and edges. Okay, so now I'm going to talk about depth first and breadth first in a completely different context, because sometimes you really, really, really don't have a viable choice between the two. Now, I'm going to show you an example of directory traversal. Now, this is not a graph, okay, because a graph would be, a mesh with nodes and lines. This is a tree structure, and tree structures are different than graphs. You start with a single point, and then it branches off, and then I have lots of more little branches, right? So admittedly, the two are not the same, but I'm still going to use the technique of two different choices of traversals. So what I'm going to be doing is I'm going to be listing all of the files at a starting location. So pick a spot in the tree and then say, I want to see every single file and directory below me. Okay? Make sense? Cool. So here's what it looks like. I'm using a breadth first technique with recursion. So if you give me a starting folder, the first thing I'm going to do is list all of the files that are in the folder. And then after I've listed the files, then I'm going to look at all of the folders. And if there's a folder, I'm going to stop where I'm at. So I list all the files. And then I come to the first folder, I say stop. And then I go down to that guy and list all of its files. And then find the next folder in its list. And I stop and I go down to that. And so I'm file centric. In other words, I'm more interested in the files than I am with the nodes, right? Okay? So this would be a breadth first kind of approach. And then it's recursive because I just call it over a second time. Okay, so I'm just going to run this. And I'm going to pick my starting location as C:\/ users image gray documents. And ding. Okay. There's all of my documents that are in my machine here. And it kind of even looks right. I mean, it looks even in alphabetical order, right? The last folder in my list was something called Visual Studio 2017. And then I have some code snippets and a start page and templates and visualizers. And so this is a listing, and it's just conveniently sorted in a way that kind of makes sense to me, okay? So here's another technique. This is the depth first technique. Not quite the same as before, but just bear with me. So here I'm doing the folders first before I do any of the files. If I come across a folder, I'm going to stop what I'm doing and do the folder. If I come across another one, in other words, you won't see any files at all until you reach the end of a folder. In other words, I start here and I go down one. Nope, I'm not looking at any files. And then I'm going to go down, whoop, not going to look at any files. This one doesn't have any subfolders, so therefore now I'll look at the files. And then I'll pop back up, okay? So that's how this guy worked. It's still recursive, unlike the other technique where I had a choice between recursive and using a queue. Okay, this is still using recursive. It's just a slightly different technique on whether or not I want to show files first. So I'm just going to change this, and we're going to start again. And I'm going to pick the exact same thing I did before. Users, image gray, documents, and wait a minute. Okay, some of this stuff kind of made sense, but why do I have like a desktop document? In other words, I didn't get to the files that were in my folder until the very end. And so this is not in sorted order, is it? Not sorted by any technique that I'm familiar with. And so in this tree structure, you almost always have to go with breadth first as a technique, because you want the output to come out sorted. Now, is it faster using one technique for the other? No, not at all. There's no performance increase in either technique. It doesn't really matter. Does one skip over files? No. So they're both equally efficient and do an excellent job. It's just that when I'm trying to do this thing, I want these things to come out in a meaningful order, and meaningful order in a tree structure means breadth first. Okay, you guys making sense of this? Good. So we have reached the end, and I'll see you guys again in the second half of this chapter.